So I quickly want to just go over the prerequisites, the setup stuff to make sure that everything is set up, that you all know what needed to be set up. But you all should have gotten the setup instructions in emails beforehand. Um, so we're going to be in this workshop, be working through Git, GitHub Desktop, and GitHub. So there's many ways to kind of interact with Git. A lot of people know about it through a command line interface, whether you're working through on a command line like this, kind of doing git, add, blah, things like that. But that can be really intimidating to a lot of people. It can have a much higher barrier of entry. So in this workshop, we're going to be doing through a GUI interface, a graphical user interface with GitHub Desktop. GitHub Desktop is not the only graphical Git client out there. There are many other ones. Most text editors or IDEs have some form of Git integration, whether that you're using VS Code, whether you're using RStudio, PyCharm, all of these ones have some kind of Git integration that often has every feature that GitHub Desktop has, and often potentially more. And there are even third-party ones like GitKraken that have a lot of features as well. But we needed a kind of a simple common denominator that has a streamlined interface that everyone could get started with. And so that's why we chose GitHub Desktop. It's free, it's simple to use, and everyone could use it as a common denominator. If after the workshop, you want to use these tools in whatever text editor you use, whether that's RStudio if you're an R person, or PyCharm if you're a Python person, or VS Code. The interfaces are going to be pretty similar. They're going to have similar buttons, maybe in slightly different locations, but they're going to operate very similar. So this should be a transferable skill, whether if you want to simplify your workflow afterwards. So what you're going to need for this webinar is you're going to need a GitHub account. So you should have done that beforehand. Go onto GitHub and sign up. You'll need GitHub Desktop installed. And once you launch GitHub Desktop, it should have asked you to connect it with your GitHub account. And there's some optional things that you could have done. If you install Git directly, you can do some of the command line stuff instead. And if you install an IDE or a text editor like VS Code, RStudio, things like that, it makes editing the files a lot easier. If you already have it installed as well, it makes editing the files a lot easier. Yeah, so let's jump into what a version control system is. Yeah. So a version control system like Git is basically, so we're moving on to chapter 2, if you are in the tutorial now on the website. So a version control system is a system that basically is going to track the changes you make from files that you add. So you can add a number of files, and then as you change those files, it's going to be able to it's not just doing a backup like Google Drive or OneDrive or Apple iCloud or anything like that. It's not just backups, but it's also keeping track of the changes you make between those snapshots you make. So I'm sure a lot of you can empathize with this kind of a situation where you're working on a paper and you name it, final.doc, and then you get some comments back, and then you have final revision 2.doc, and then you get more revisions. So final revision 6, comments.doc, and this keeps going on and on and on. And so you end up having 12 different copies of the same file, all in the same directory with slightly different names, and maybe they're not even numbered. So if maybe you do number them so you know which one's first, which one's last, which one's in the middle, but maybe you don't number them. Maybe you just have final with comments from Joe, final with comments from Sarah, and so you're not even sure the order of them. So that can be really difficult and frustrating to work with sometimes when you're in the middle of that. And so this is the problem that Git is designed to try to alleviate and help with. Instead of having these different versions of it, you would have one version and then you can just keep track of the changes you add. So some of the key features of a version control system is it has history tracking. It helps keep track of those changes I was mentioning. It also allows collaboration very easily, where multiple people can be working on two different versions of the same code or documents, and then easily merge their changes together. It also allows people to comment on things and then work on how they want to resolve those comments. It allows you to do what's called branching and merging, which is basically like you have one idea of what you want your thing to be, and you want to try out something different. Maybe that's adding a new thing, a new feature, or maybe it's like fixing something. And then you work on that for a while without having to ruin the state you have. So you don't have to do a thing where you have a working code base. You try to fix something, but then you break it while you're fixing it, and then you have to figure out what broke before. You can keep the working one while you work on a fix as two separate versions very easily. And then you can merge them in when it's ready. And then you can do backups and restores. So if you ever go down a path, you're trying to fix something, you break it, you can just roll it back. So I've been talking about this as an abstract thing called a version control system, and not specifically saying Git. What is Git then? Git is a specific version control system. It's an implementation of a version control system. It is the most popular. It is when people say version control system, they almost always mean Git. And when people say Git, it is a version control system. So that Git is just by far the most popular one. It's the one that you'll see usually used on GitHub and GitLab and all of that. There are some alternatives to Git that are just not nearly as popular. There are some ones that were more popular in the early days before Git was invented, or before it really picked up steam, but Git is the most popular one nowadays for a variety of reasons. So there's a good number of reasons for this, similar to some of the reasons about version control systems in general, but some of the things that make Git a really good version control system is it's much better being a distributed version control system than some of the other options. It's the most performative one. It's very fast compared to some of the other options, and it has very good other features with branching and merging and backup features with its integrity system. So just talking real quick about, to give you a mental model of what's happening. So if you have in this picture with the documents, a snapshot of your code of a document, and then you make a change, you add a line, you have another snapshot, and you add some more lines, and you have another snapshot. This is what Git is doing behind the scenes. It's basically just creating these new snapshots that are linked together. And if you instead want to make a branch, if you want to make two different versions of your code, you basically have a snapshot of your code, and then it goes into two different directions, and it keeps track of both directions of the code. And when you're done with those two different versions of the code, you can merge them together, and those different changes in different parts of the code can be integrated together again. So now we talk about real quick, what is GitHub? GitHub is a web-based platform for using Git. So Git is a version control system that can be used locally on your computer. It can be used independently. You don't have to use it on a server. You can just use it completely on your own computer. You can deploy it at your university on your own server and all that. But most people use it through a cloud provider that handles most of that for you. And GitHub is one of the most popular ones. And so that handles a lot of the nice things about Git for you. And so that's what GitHub is. It's different than Git, but it complements with Git very well. And as we talked about before, GitHub Desktop is a GUI client that makes using Git much simpler. You don't have to do all of the command line terminal stuff. So with that, we're going to jump into chapter 3, and we're going to start actually using GitHub Desktop, and we're going to start actually doing things with Git. So over here on the left, we can jump to the next chapter or at the bottom. So we're going to talk about a Git repository. So a repository in Git. A repository in Git is a singular place that to store one project of your code. So you can have many repositories, but like one repository, you can start it, and Git will track all of the files in that repository that you tell it to track. So typically a repository, you'll go to a folder, you'll tell Git to start tracking the files in that folder and all the subdirectories, or you'll tell it to start a repository there, and then whatever files that you tell Git to track in that directory and subdirectories, those will be the ones that it will start tracking snapshots of. And so a repository usually is one project instead of like multiple projects. It's usually one project that you are tracking, and a repository doesn't track files that are outside of that directory. So you don't track the files like one directory up or anything like that. It's all the files in that directory or below. So if we open up our GitHub desktop, and we look at this step for creating a new repository. So we're just going to follow these steps and we're going to do them together. So in GitHub desktop, we're going to create a new repository by going to the file menu and click new repository. So you can do that by going up here, file, new repository. You can also, just to show you real quick, if you go into the current repository, you can click this add button and create a new repository. Both will do the same thing. Once you get to that, you get this little dialog box and it asks you to enter some information about the repository, about what you want it to be called, a description for just an overview of what it is, et cetera, et cetera. I have on here a picture of what this dialog box should look like and information on what all of these things are. So we have like the description, we have the local path. This is going to be where it's being saved to, the directory is being saved to. If you want to initialize the repository with an empty README file, a README file, if you've gone to a lot of repositories on GitHub before, the README file is kind of the file that just tells you what's happening in this repository. It's like an overview file. You can set a git ignore template if you want. So a git ignore file, we're going to go over that later, but so we don't really need to talk about it now. So you can skip that for now. And you can optionally also set a license in your repository. We will also talk a little bit about license if we have time, but licenses basically tell other people if and how they can use your code. Whether it's a very liberal license and anyone can use your code however they want, or if there's restrictions and things like that. And so there are a number of common licenses that you can choose from as well. So I'm going to enter Git webinar, and let me find that webinar. So I'm just going to enter some information for this. I already have a local path already filled in for me. I am going to initialize it with an empty README because we're going to use the README file in a minute. And if you don't do it, you're just going to have to create the file later, which you can do as well. But I'm going to start with a README file. And I am going to just start it with one of my favorite licenses, but you don't have to add a license if you don't want to. And on the tutorial page, there is a link to a website that will walk you through some license choices, what they mean, and the licensing chapter also has more information about how to find out about licenses. So once you have done all of that, you can just click this Create Repository button right here. And once you have created the repository, you'll see that in GitHub Desktop, your current repository is switched to Git webinar or whatever you named your repo. And you are now have created this repo. If you go into repository and show in Finder or Explorer or whatever it is, if you're in Windows, it should be Explorer or whatever it is your file manager. You open it up, you should see that this directory has now been made for you with all of the files that it needs to make. So we see that it's been made, we verify that it exists and everything like that. And if you scroll down through this chapter a little bit, you can see there is an alternative method that we're not going to do today about how you can create a repository directly on GitHub. GitHub allows you to create a new repository and then clone it. It does, behind the scenes, it does similar commands to what this does, but some people like doing this way, some people like doing it the other way. Both are fine, but it's documented there if you want to try it out sometime. So that's how you create a repository. This repository only exists on our local machine currently. It is not connected to GitHub at all. It's just a local Git repository. So if we move on to our next chapter, chapter 4, and we're going to start working on some kits. We're going to do those snapshots that I talked about. So when I was talking about how Git makes snapshots of your code as you code along, those snapshots in a more technical term are called commits. That is the language that Git uses. So if we open up our repository in GitHub Desktop, which it should already be open, you can open up the repository in your default text editor. So that can be done in repository. Down here, mine is open in Visual Studio Code, or you can do it right here. If you don't have any of the text editors that are commonly used, like VS Code, RStudio, or anything like that, you can also do show in Finder and then open these up in Notepad or text editor, any of the ones that you're that are on Windows or Mac, that will open them up by default. So if I wanted to open it up in text editor, I could just open with other, and then I could find text editor in here all the way down, text edit. I could do it that way. If I don't have something like VS Code or RStudio installed, you can do it that way. But assuming you have something like VS Code or RStudio or something like that's installed and it's been configured, then you should be able to just do open in Visual Studio Code or open in Visual Studio Code or RStudio or PyCharm or anything like that. One second, this is window, there we go. Okay, so I zoomed in on this before, so tell me if it is not big enough. Yeah. So now we're going to edit our README file. So if you open up your README file in your text editor of choice, also, if I am going too fast, I just realized I might be going too fast for people. Should I slow down a little bit? Do people need a minute to catch up to creating the repository? Waiting a minute to see if anyone types in the chat they need a minute to catch up. Okay, if anyone does need me to slow down or anything, just post it in the chat. So We have our README file opened now. And you're just gonna add some stuff to the README file so that the file is changed. In the chapter 4 on the tutorial website, I gave you an example that you could just copy and paste and put it directly in here. You could replace all of this if you wanted to. No, I did not copy it. So if I go over here, I could just click copy or highlight it and copy it, but I could just click copy and then go back to Visual Studio Code, and then I could paste it or I could add it at the bottom. Either is fine. And once I've edited the Git repo, the README file, making sure my changes are saved. I'll give everyone a second to do that. And we can go to our GitHub desktop, and we can see here that the changes tab on the left now shows that our README file has been changed. It has all of these lines that are added as green, and they have little pluses next to them, showing that all of these lines have been added to the file. Now, as a little note, real quick, if I instead replaced the whole file with that, you can see that on the left, it shows these lines in red with minus signs showing that these lines have been removed. So GitHub Desktop and Git in general is showing us that the specific lines that have changed. It's keeping track of not just what file was changed, not just that the README was changed, but it tells you exactly what was changed. And this will be true for every file, for every commit you make. It'll tell you specifically what was changed. There are actually a few exceptions to this. If you commit certain types of data that are basically what are called like binary format data, and those are going to be like pictures. So if you commit like a JPEG file and then you even changed one pixel of that file, it's going to change the file in a very big way on a data level in the binary format data. And so Git is not going to just be able to be like, well, this one pixel was changed. It's going to look very different because of that. So those kind of files you can't do a line-by-line analysis of. So any kind of these files that are hard to look at, pictures, executables, things like that. But any kind of thing that's more or less like plain text files. So markdown files, code files, all of those kind of stuff, it can do like line-by-line analysis of. So we are going to commit this because right now it's showing us what's changed, but we haven't actually told it to make a snapshot yet, a commit. What we do for that is we select which files we have changed that we want to add to the commit to make this snapshot. Currently, we only have one file, so I'm going to select that file. But if I had multiple files, then if I opened the wrong text editor. If I went into this file and I made some changes, and then I save it, it shows up. Because now I have two files, and so you can choose which ones you want to add or not add. So I'm going to add this README. Now down here in the bottom left corner, we have where the message we want to attach to this commit, this snapshot. So when you are looking at your history, you don't want to just see this big line of snapshots, these commits, and not know what they are. So we attach a message to it so that we can easily quickly see what that code change was. And then we can go into it and see it, but we want to be able to quickly review what it was. So I'm going to add the first line as like a summary one, and then if you want to add a longer description, you can. So I'm going to add a little summary tag right here that's like add initial README file. I can add a summary file if I want. Initial README file for the GitHub desktop webinar. Remove initial lines, replace with example. That's what I'm adding. That's probably longer than I would normally add, but for an example. There are in the tutorial some little rules of thumbs for some commit message best practices, just a few. If you want to read those, go ahead. But they're just kind of guidelines. So once you have done that and the files are added that you want to add, you just click commit to main. And we've taken a snapshot, we've taken a commit. And if you now go over from changes to our history tab, we can see that that commit is now in our history. So we can see all of the files that were added, which in this case is just one, and we can see what was changed. You'll also notice, as just a little interesting point, that there was a commit made automatically when we made the repo. The initial commit was made automatically for us by GitHub Desktop that made all of the initial files. So that one's already, we get that one for free with the GitHub Desktop. Okay, so that's how to do some basic committing and stuff. How's everyone doing? Everyone caught up with all of that? Cool. Great. We're gonna move on to chapter 5, viewing and managing history with GitHub Desktop. So we're gonna make another commit. And so we're gonna go back to our text editor and open back up our README. And I just want you to add like a couple more lines at the end of this file. I switched keyboards, and so I keep messing up copy and paste because they're in a different spot. So I have an example. If you look at the top of chapter 5, we're going to be looking at how to look at commit history and a little bit more about diffs, which we kind of mentioned before, but I'm going to look at it more in depth. And so I have a test commit, some lines for a test commit at the top of this chapter. You can just copy and paste them, or you feel free to put really whatever you want. This is going to be your repo at the end of this to do with what you want. So I'm just going to put those in test commit. This is a test commit for demonstrating GitHub Desktop features. I don't think I'm going to use this README for real documentation. So once I have that, I'm going to do the exact same process. I'll go back over to GitHub Desktop and add a little commit message. Add test commit section to README. I think at this point, I probably don't need a description. It's a pretty simple commit, so I can just add a little short summary. And I'm going to click commit to main again. Now, if I go back over to the history, we can see once again our commit history again, and it shows the differences. It shows what was changed and what was added. And you'll see, at least on mine, depending on how you did this, it shows a subtraction on this line where it says step 3, but it still has step 3 on the right. And what that is showing is you see that on mine it has this little like X cross with a carriage return symbol at the end. And that's basically what happened here is there wasn't a new line before, and so it's showing that this line was changed because I added a new line there. And so that's a thing that could be confusing. So, and then I'm going to go back to show it how things can, I want to show in different ways that your diff can show up. So I'm going to go back to here again, and I'm going to remove this line. And I'm going to change it from this is a test commit to this line demonstrates a change. So I'm keeping the this here, but then everything after that is it's on the same line, and I'm keeping the this, but everything else after it's the same. So it's like a variation of the line before. And I'm just going to commit it as test, change a line and then commit test section. And I'll commit that. And you'll notice in this one, instead of showing that the whole line was changed, GitHub Desktop and Git in general is smart enough to know the specific words that were changed. So you'll see that in one of our previous commits, it showed entire lines were removed when we removed entire lines. In this one, when I changed the end of the line, it highlights just these words and says that these words were added. So that can be really helpful if you're just changing the spelling of a word. For example, if you have a typo, or if you're in your code and you have a little error on one part of the code, you can change that, and Git will be able to tell you the specific change that happened on that one line, the characters that change and things like that, which can be really helpful for figuring out if something broke later on. You can know exactly what was changed instead of the whole line. So that's a thing that you can do. So, and then one other final thing you can do with viewing differences, which we also call diffs, when you're looking at the difference between two commits, is you can also, if you click on a commit and then you hold shift and you click on another commit, it will highlight multiple commits, and you can see not the difference on that one commit made, but the difference between the state of the code at one commit and then the other commit. So it's a difference between all of the commits. Or I can do the whole repo, and it tells me everything that changed since then. Or I can do this, and it can tell me everything that's changed. And so if you have a really long running thing, if you have something that's really long running, then you can see all of the things that changed over the last month or 2 months or anything like that. That can be really, really helpful. So what happens if we make a commit, if we make a snapshot, a change, and it's not just necessarily a documentation change, but we're working on our code or working on a model or something like that, and we push it, we commit it, and maybe someone's using it or anything like that, and we realize we broke something. Well, one thing you can do is, if it's just like one commit, you can revert changes in a commit, and that will undo that commit. Well, that will, I want to be careful with my language here. That will restore the code base to before the commit. Restore the code to the state it was before the commit, the code itself. So, but it will keep the commits there. So if I revert, what you will see is it undoes what I did, but in a way that it makes a new commit that undoes what I did. So it doesn't like undo as in like remove the commit, but it makes a new commit undoing that. So it's like, an inverse commit, the inverse of it. Then that you can revert commits that way. If you start playing around with the menu in GitHub Desktop or other ones like RStudio or VS Code, you'll also see undo commit as an option. You can do undo commit, where what undo commit will do is it will, or in VS Code or PyCharm or other ones, it might be called drop commit as well. It might be called something like that instead. What that will do is it will just get rid of that commit. It'll just get rid of it entirely, which can be really nice and useful because it will, it's like you didn't do it. But the dangers of that, as a warning, and all of these dangers are in the tutorial. If I go down to this section, the dangers of this, if you read this section, is basically if you've taken your repo and it's available to other people, if you put it on GitHub, the undo commit option rewrites your history because it removes the most recent commit. And so if you have a repo on GitHub and I have a copy of that repo and I'm working on it, things too, and then you remove a commit that I've already downloaded, then we have two competing versions of the same repo that create big problems. And so undoing a commit is generally fine to do if you have everything locally, but as soon as you push it or sync it to GitHub, it's something you generally don't want to do. So someone asked, does there need to be a time before things show up in the history tab? There shouldn't need to be a time. I don't know if that's just something with your GitHub desktop lagging or something with your computer lagging. Generally, it should be pretty instantaneous. If it keeps happening, we could troubleshoot it afterwards. Okay, so we are now going to, is everyone caught up with all of that with just how to make commits and view history and things like that? If we're all good, I'm going to move on to branching and creating a branch. Cool. Okay, so we're going to talk about branching in GitHub Desktop. So as we mentioned a little bit ago, in Git, you can have a line of code, and then you can branch off of that to make multiple lines of work at the same time that you can merge later or try out different things or use in different ways. So to create a branch, we're going to go back to GitHub Desktop, and there's a new branch option. So I'm going to go to, if you go to, there's two ways to get to this. You can either go up to branch, new branch, up at the menu, go to branch, then new branch, or if you click on the branch you're on, which is this middle button, you can also click new branch. Both of those work great. So you can pick a name for it. So you could just pick like feature branch or awesome feature or something like that. I like to I almost forgot how to spell the word feature. I like to preface my branches with the type of thing it is and then a slash. This is a fairly common convention, but not a lot of people don't do it. So a lot of people do. But the reason why I like doing this is it gets you something that's pretty nice. If I go to a different repo, that is just one of my repos that I work on. If you notice my branches, Git treats this initial thing with a slash as basically a folder. And so all of my feature branches, I have a folder called feature, and then everything is underneath it. I have a folder called docs, and all of my docs are. So this branch was called, docs add info only metrics. And then I have like a branch that's feature done domain other language, like feature slash done domain other language. And then a lot of Git clients will treat those as folders themselves. So you'll get them organized in a folder structure instead of having everything in a flat structure where you have like all of your features next to each other. And so you can collapse them. That's the only reason I do it, is for organizational reasons. So I can have all my package like organized one, my bug fix ones together and all that. That's the only reason I do it, is for organizational reasons. Oops, did not mean to click on that. So that's the convention I follow. Some people follow this thing when you're working on an open source project that you should use like your name, but that's not that common. Like you preface your name, that's not that common. On your own ones, you should come up with a branching strategy, like name strategy, and just kind of stick with it. So I am going to call mine feature slash awesome feature. And then on the tutorial, there is a few different common like categories that you'll see in branching: names, features, bug fix, hotfix, docs. Those are all pretty common. So after you've entered your name, just create the create branch button, and then you'll see that your branch on current branch has changed. And now that we're on a new branch, all of those commits from before are still there. So we still have all of the commits from before, because we're making a branch from our current where we were before. So we're branching off from where we were before, which still had all those commits. So if I want to make something new in this branch, I could go back to my default text editor, for example, VS Code. And instead of modifying the README, I am going to add a new file here, and I'm going to call it awesome feature.markdown. And I have in the tutorial page an example content that you could just use, but you can feel free to fill it with whenever you want. So I'm just going to fill this with that. So this is an awesome feature. It will be a new feature to our project and enhance the user experience and improve performance. It is a great feature. So once I have this awesome feature, we are going to do the exact same thing that we've done before. We are going to commit this this new file, but now it's going to be on a new branch. We're going to head back to GitHub Desktop. You'll see that on my GitHub Desktop, I'm on the History tab still. Yours might be different, but I'm going to move over to Changes. And I'm going to add a little summary thing. Add new feature file, awesome feature.markdown. I don't think I need a description because it's not a very big change, but I could add one if I had more than just 2 lines of code. I am going to commit this. And you'll see that this now shows up as a new commit in my history. But if I switch branches, which you can do under the middle button, current branch, and switch it back to main, that file is no longer in my commit history. That commit is no longer in the history. And if I go back to VS Code or my text editor of choice, that file is also not there. It is gone. So we can see that it kept track of the file. It took a snapshot, but then when we switch branches, that file was only part of the snapshot of that branch, and so it's no longer there. But it's not gone. So if we switch back branches to our feature branch, which our commit now shows up again, we can see this file is once again there. So it's not gone, it just only lives on that branch. Great. How are people doing? People good? Are we following along? Are we caught up? Great. Great, great, great. Okay, so this act right here, I'm going to quickly talk about. When you move from one branch to another branch is called checking out a branch or switching branches. So I can switch to a new branch or I can check out a new branch. Both are the correct terminology. There are different Git commands that do the same equivalent thing, and one is called git switch and one of it is git checkout, but it's switching branches. So I am going to go to chapter 7 now, revisiting old commits in GitHub Desktop. So what if in a scenario, let's imagine a scenario where you've been working on a project and you get to a point where you have something great, your documentation's great, or a feature's really good, your model's doing good, or something like that. And you're on a certain branch, whether it's main, develop, or feature branch, and you make 2-3 commits towards working towards something, and you realize that the path you're going down it's just not working. One of the great things about Git is it allows you to both look back at your old state of your code and go back to your old state of your code to like roll things back. So we're going to talk about both how to just look back at old states of code and how to like add an old state of your code, continue on to in a new direction, because those are two different things that we have to mention and talk about. So if we go back and if we're back in GitHub Desktop, this is a commit we just made about adding our new awesome feature. But I'm going to say, yeah, so if we wanted to view the code at this commit, change a line in the test commit section or a couple commits back for what if you named it something different, you can right click on that and you can click on checkout commit. So in the same way that we checked out a branch, you can check out a specific commit as well. Now, when you do this, you're going to get a scary message. And it says, and there's a little warning icon, it says checking out a commit will create a detached head. You will no longer be able to be on any branch. Are you sure you want to check out this commit? So what is a head? What is a detached head? Should you do this at all? Should you turn back and be scared and never use Git again? So what a head is, in Git, head is just the term they use for the pointer to your current location. So the head is wherever you currently are. So generally, your head is the end of your current branch. So if I click cancel right now, the head is not this commit, but it's like the end of this branch. So when we make a new commit, it'll move to the new commit. It'll move to the very end of this branch. If I switch to main, it is now the end of main, right? It's just like, it's a pointer saying, where are you? You can think of head as, where are you? A detached head basically means you are the pointer to where you are, your current location is no longer on a branch, but just on a specific commit. And that's dangerous because commits on branches allow you to create this history with it and do these merge requests from one to like merge things in and things like that, like to reconnect your changes later when you're done with them and you can combine them together. But if you check out just a single commit, it won't be on a branch. And so you won't be able to, if you make new commits from that, If you make new commits from that commit, then you run the risk of losing them. They won't be associated with a branch. You won't be able to, it'll be much more difficult to merge them in, to combine them in later. So the key of this is checking out a commit is really great for looking at old code, but it's not good for making changes to old code. So if you want to look at an old piece of code, so like look around to see what it was, what you were doing, just read the code, that's when you want to use checkout commit. If you want to make changes to the code and go in a new direction, there's a different way to do that. Do we need a minute to catch up? I see that in the chat. Also,
I guess I don't understand if checking out is just checking out, is just looking around. Why is it dangerous? If you're
so okay, it's not. This isn't dangerous to just look around. So I'm going to check out right now. This isn't dangerous. I can look around the code. I can go into it and see all of that. The only dangerous part is if I then wanted to go in here and say, changes, make some changes, right? If I then make some changes to the file, and if I'm not just looking around, if I make some changes, and then I want to commit it, and do like some commit message. If I commit this, this commit isn't going to be on a branch.
And a commit. So what is the logic of restricting? Why is checkout not restricted? Like, why does it let you make changes also if it's not the preferred approach to making changes?
It lets you make changes because Git is not, because all of these are just text files. And so these Git basically is letting, like, Git's not going to restrict what you do to your text files. They're your text files. You can do whatever you want with your files. Git lets you go view your files however you want. And then if you want to make changes, you can. I think there's a point a little later that talks about branches, a point about branches, but I think it would be good to talk about it right now as like a key concept of branches. I'm trying to I'm trying to find it where it is in case anyone wants to look at it while I'm talking about it. What chapter it is. Proving. I think it's in the PR chapter. We'll come across it when we get there. I'm just going to just talk about it real quick because I think it's a conceptual thing that will help to understand this. So there's this idea that this misconception that commits belong to branches, but that's not actually how it works, because if we look, if I switch back, this commit, revert change align in the test commit section is in our history and we're on main, right? But if I go to feature awesome feature, it's telling me I have uncommitted stuff. So I think I can do that, and then oh, 1 second. It's all. I'll just do this, and then I want. Okay, is that good? Changes. Discard changes. That's what I want. Okay, great. So the same line, revert change a line in the test commit section, is also on our feature branch. So that same commit is on 2 branches. And that's important because a branch is just a label for a commit. So when you make a commit, it can be on 1 branch, it can be on 2 branches, it can be on 3 branches, because the label, the branch is just like a label for the commit. And so what happens when you check out a commit, when I check out this commit, the reason why this can be a problem is this commit exists currently on 2 branches. So it doesn't know which branch it should be checking out, basically, and like which branch it would like branch off of, because it actually exists in 2 branches, and it could exist in many more, because a branch is just a label for a commit, and instead of the other way around. And because of that, when you check out a commit, it has to just be in this like branchless state, because you're looking at the commit directly instead of in the context of a branch. But then because Git doesn't hold your files hostage, it's just like looking at the changes of your commits, changes of your files, you're still free to make changes to your files. And then once you've made changes to your files, Git is going to do the best it can to be like, well, this is what you did. It'll do the best it can. And then if you do commit this change will be connected to that commit. It'll know that it happened after that commit. It just won't be on a branch, and you can recover that. This is a pretty more advanced thing. Like, you can recover it by putting on a branch after the fact. It's just very difficult. So you just don't want to do that. It's just a very difficult thing to do, and it's just Git's doing its best job it can. So checking out a commit is like good for looking at your previous code, but it's not good for making changes and like branching off of that. Does that make sense? Okay. Now, on my notes on the side, I have to go back to the chapter I was in. Okay. So we've looked at that. Now we talked about the dangers of all of that. But like, what if we do want to make changes to an old commit? What if we want to come off of that? So I'm going to go back to this branch. And so the way to do that is, if the problem comes from the fact that when we check out a commit, we're not on a branch, why don't we just create a branch from the commit? And that's how we solve it. And that's just an option right here. So you can create branch from a commit. And so that will, after the fact, create a new branch coming right off of that, right there. So I can just say create branch from commit. And I could call this anything, like feature new old branch. And now that we have this, we could just look around, but we can also make changes. Generally, the reason why you don't do this by default all the time is then you're just going to end up with a lot of extra branches you don't need, and then your list of branches is going to get a little bloated. And then you would, you would eventually want to clean it up, and you'd have to go through this annoying thing of deleting branches and figuring out which ones you need and don't need and all that. That's basically the reason why you won't do this by default, is that you just get branch bloat. Okay, are people good with that? Does anyone have any questions about that, or should we move? Should we wait a second, or should we move on to the next one? Are we good? Great, great. So we're going to talk a little bit more about local repositories before we connect it to GitHub. The last thing I want to talk about before connecting to GitHub is your gitignore file. So when we created our repository back in chapter 3, there was an option to do gitignore, and we left it blank at the beginning because if you fill it in at the beginning, it gives you this big long template for the type of repository you're doing, which I think in general is the way to go. But I wanted to show you exactly what gitignore does. So gitignore, basically what it does is that there's a lot of projects, if you're working in various code languages or frameworks, that will create a lot of files that you don't want committed. Justine made a good point in the chat about how a lot of clients will let you view commits without actually checking out the commit. Also, GitHub website itself, once you've connected it to GitHub and pushed it, you can view the code without actually checking it out. So generally, when I want to view code without and just look at it, I usually do it a different way than checking it out. But yeah. So a lot of programming languages will create files that you don't want committed. For example, if you're building an executable, for a deployment of your project, you're going to have like a build folder that has all of the build dependencies and stuff like that as it builds. You might have a virtual environment in your repository. Python compiles the first time it runs a piece of code, it compiles it to bytecode as a .pyc code. If you're using Sphinx or Oxygen, you have a number of built documentation files you don't want committed, like HTML files usually, that you often don't want to build because they'll be built automatically when you push it. So there's like a number of files that you might not want committed. You might not want security things if you have passwords and stuff that are needed for your code, but you don't want them committed, and you just are going to share them to someone if they're using it. So there's a number of reasons you might want things not committed, or maybe they're really large data files if you need data for your data visualization or data processing thing, but there's several gigabytes, 10 gigabytes or whatever, which is larger than you can put on GitHub. So you might not want to commit those. And so the .gitignore file basically tells Git, don't commit these. Like, don't commit either these specific files or this file for like pattern that you can put. And so I have an example one here for an R project. This is like a template. You can look up templates for your language that will get most of the things you might use if you're using R or Python or a specific framework or anything like that. And so this one ignores, I don't use R that much, so I don't know all of the things in here, but it ignores history files and session data files. It ignores RStudio files that you probably don't want committed because they'll be specific to the user, and a bunch of other things that might be specific to the user. You also often might ignore, if you're using VS Code, it might create a specific folder in your wherever you open up VS Code that are like your user settings. And a lot of IDEs or text editors do the same thing. So those are basically what you would add here. So we can, in our default text editor, we can go in here and we can create a .get ignore. And if I want to, you can add specific things in here, but I'm just going to copy this R template one and then accidentally open up a different IDE again. And I'm just going to put all of these in here. And so you'll see that like some of these might be specific file types. Some of these are folders. Some of these, you'll see the asterisk is a pattern. So it matches, like it's a wildcard for any kind of pattern. So this is vignette folders, anything inside the vignette folder that is an HTML file. If I, for example, I could make like a new entry that's like a scratch folder. If I had a scratch directory, I could put scratch here with a slash and it would ignore everything in a scratch directory. So you can add that and it'll just ignore it and it won't ask you to commit it. So like the files here that GitHub Desktop asks you to commit, they won't show up at all. So you won't accidentally commit them. They won't show up. So once we've added our git ignore, once we've added this and we've saved it, we can go back over to GitHub Desktop and we can add a little commit message like we've done before. Add git ignore file. I think I actually want to do this on my main branch. So I'm going to switch branches. And GitHub Desktop has a nice little feature that if you are on a branch and you make changes and you try to, but you're on the wrong branch, you can switch branches and it will try to bring those changes with you if it can. So I can say, bring my changes to main, and I click switch branch, and I don't have to redo anything. The git ignore is still there, even though I switched to main. So I can just do that and it's already there. There are times when that might not work if your changes conflict with something on main. If you've changed something, then you'll have to try to resolve it, which we will get to resolving those kind of things in a couple chapters. But a lot of the times you can just be like, oh, I want to bring that over with me, which is really nice and convenient when you accidentally are on the wrong branch. So I'm going to commit this. And now I can go over to my history tab and I can see that I have my git ignore. Cool. Everyone good with that? Okay. So far, everything we've done has been with GitHub Desktop for our Git client, but it's all been local. It's all just been using Git. Nothing that we have done is actually used like GitHub on the web. And the reason for that is Git and GitHub are two different things, where Git is the actual version control system that versions your files and lets you go back and make branches and merge them and like all of that. And GitHub is a remote place where you can take your repository and keep it in the cloud as well as locally and let other people work on it. You can work collaboratively with other people, or you can just have like backups of it as well. And they complement each other very well, but Git is the actual version control system that you can just run locally or on a different server and all of that. And so all of these things that we've done don't rely on GitHub, other than the fact that they make GitHub Desktop. But now is the time when we are going to connect our repo to GitHub. And we're going to push the changes. We're going to connect it to GitHub and publish the changes and push them to GitHub. And so that will be in both places. So as a little aside, as mentioned in this section right here in chapter 9, There are other hosting services that do like cloud Git stuff. GitHub is the most popular one. There's also GitLab and Bitbucket. There's pros and cons to all of them. GitHub is the most popular. It has most like open source projects are on GitHub. It has a pretty generous free option, especially if you connect it and verify you're working as in an educational institution or as a nonprofit or anything like that. It's pretty generous with their free options. GitLab tends to do more things with enterprise things. They also have a really good and potentially better automated bot system, like their CI stuff, whether you would want to do automated testing or automated build stuff, their stuff is a little bit better. And I'm not actually as familiar with Bitbucket. Not that many people use Bitbucket, but some people do. But they're all fine choices. So we are going to connect our repo to GitHub and create a remote repository. So if you go into GitHub desktop, we go back to our GitHub desktop, and in the top corner or the middle section, we have this publish repository button. And we publish this repository in GitHub. Also, as a side note, back to the other options, GitLab and Bitbucket and stuff. If you choose to stick with GitHub desktop, I don't know, or I don't even think GitHub desktop will connect to the other ones besides GitHub. I don't think they connect to GitLab or Bitbucket or anything like that, but the other Git clients, like using it integrated with your IDE or text editor, VS Code, PyCharm, RStudio, or using a third-party GUI application like GitKraken and things like that, do. So as a little mention. So we're going to publish our repository to GitHub. So if we publish it, we're all just using github.com. I assume none of us are using GitHub Enterprise. That's like a corporate, generally like a corporate thing that your company's paying for their own version of GitHub. So on GitHub desktop or github.com, you fill in the name. We already added a name at the beginning, so it'll autofill with the same name. You could theoretically choose a different name if you wanted, but generally you keep it the same. And the description should fill in with the description you added before if you added a description. And then you can choose to keep the code private or make it a public repository. A public repository means that anyone who has the link to the repository can view the repository. That doesn't necessarily mean they can have all of the same rights to the repository. Like, they doesn't necessarily mean they can make changes to the code. There's security options for that, but they can at least see it. That's what being public means. Versus being a private repository, no one can see it unless you invite them as a collaborator. I think both are fine depending on what stage your project is in or what your project is doing. I'm going to make mine a public one, but feel free to make yours a private one. You probably don't have any organizations unless you've been using GitHub already, but organizations are like umbrellas for repositories under the same thing. So you might have an organization for your lab your lab that you work at, if you work in a lab, or they might create an organization, or your workplace, if you're working at a nonprofit or something like that, they might have like an organization for all of their code repositories, not just from one person, but from everyone goes into it. So I have a couple of organizations I'm a part of. And so, but you probably don't have it, and you probably, if you do, don't want to put your test workshop repository in that. That is what organization means. So once you've filled in all of these, we just click Publish Repository. It will take a second. And once that is done, this should be our interface. It goes back to this default interface. And I can now go back up to the repository button, and I can say View on GitHub. And it will open up the link to the GitHub for it. And you'll see that the README automatically shows up as on the homepage, which is why you often start with a README. GitHub knows knows that READMEs go on the homepage. Yeah, if you don't have the option to choose an organization at all, that just means that you are not a part of an organization. So that's fine. Don't worry about it if you don't have an organization. Yeah, if you do, that's what it means. But if you don't even worry about it. And then the README automatically shows up. You can see things like license files automatically show up because those are like important things for people to know as overview things. And then all the codes, just like right here. You'll notice that even though we've created multiple branches, we only have one of them here because we only publish, it only by default publishes the branch that you're on, like the main branch. So if we want our other branches to be on GitHub, we have to like choose to publish those as well. Yeah, so if we, yeah, this is what we can look at. We will look at the interface in a second. We're going to go back to our repo, and then I want to show us how to push some changes to GitHub. So right now, all of the changes on our branch got pushed automatically. When you create the repo, any commits on that branch automatically get pushed to GitHub. But if we open up our text editor again, and I'm just going to create a new file again. And you can see I have some text for you that you can enter, or you can enter whatever you want. But I'm just going to quickly create a file so that way we have a new commit to push. So I've created this remote test.markdown with some simple text. And I'm going to commit it, create remote test.markdown. And we can see once again the diff. Also a thing I didn't mention before. And it's in the instructions on the diff section, but I didn't mention it in the out loud. If you click on this cog wheel, you can change the diff display from the split view to a unified view that will show you all of this stuff together. Depends on how some people like one way or the other. So I'm going to commit this change, and you'll notice that instead of the publish one now, it says push origin. So when you commit something, even though it's connected to GitHub, it doesn't what's called push the commit to GitHub. It doesn't synchronize your new commit, your local commit to GitHub it doesn't do that. You need to tell it that this commit you've made, you want to push it to GitHub. So what this allows you to do is it allows you to make several commits in a row and then push them all at once, or you can push them one commit at a time. You have the choice of how you want to do it. So now that I've committed this, we're going to push it. So up here it says push. You'll see that it has this little one arrow here. That means I have one commit that's not pushed yet. I'm just going to push this. And if I go back to my repository, if I refresh the page, it now says, I now see the remote test.markdown page that shows up. It says 1 minute ago, because we just made that file. So going over the GitHub kind of interface, this main page, I already talked about how this is like the README file that is right here. It's rendered markdown. So if you are in like the README, these are like, I'm probably most of you know how markdown works, but like these are headers and things like that, and they get rendered as like headers. So this is rendered markdown. And then you have things like license and stuff like that. There's other information on the right-hand side. That little description we added is over here on the right. If you have releases, a lot of projects might have releases, and you can see those. And so if like if I go to one of my other repositories, I have a number of releases, and those are just things that will show up, whether this can be one of your repositories at some point, or if you're like looking at other people's repositories, you'll see releases there, or packages. They're usually one or the other. And then a number of things about information about engagement level stuff, stars and watching and stuff. Then over here at the top, we have branch information, what the number of branches, the number of, and how to switch branches. Currently, we haven't published any branches, so we only see main. And then you can see the repository itself. So I could go into the files. In GitHub, I'm allowed to actually view these files themselves. I can actually go and look at all of them. Then up here at the top, I have a number of little tabs. The first one is code, and that's like the default homepage is code, and you can see the code and also all of this stuff that we've talked about. Then there's issues. Issues are they're little trackers for tasks and stuff. And so the word issue makes you think they're about problems. So, and they can be. So people use issues for bugs, for example. So if you have a bug in your code, you might create a new issue that is bug fix, something, something, right? But also people will use issues for any kind of task tracker. So someone might you might do feature request, some awesome feature. It can be kind of any kind of task tracking thing. You can add in a test, any kind of text in there, and then people can comment on it. And so you can use it yourself in your own repositories to just keep your own tasks for your own features, or in a lot of collaborative repositories, whether it's big projects or little projects, people will use these and communicate back and forth in the task, whether it's bug fixes, it's features, it's documentation stuff, it's package development, logistical things, all of these kind of stuff. That's what the issues are for. They're not just like issues or problems. They're kind of any kind of task management thing. And you'll see like other task management stuff on the right that you can explore. Pull requests are a thing we're going to talk about next, but those are basically the merges when you're merging code together. Actions are automated, any kind of automated thing that you can hook up to your GitHub repo that you can explore at some point. That's like, if you want to do automated documentation building, they can show up in actions. Automated executable building, automated testing, all of this stuff can show up in actions. Projects is a different form of task management that's a little bit more like, things like Asana or Jira. A wiki it's a wiki. Some projects use a wiki for documentation instead of a website builder. Security is security settings. Insights are insight statistics about engagement and other insight statistics. And then you have your settings. That is generally the overview of your GitHub repo. And then if you're beyond your repo, if you go over to the left-hand side, the hamburger icon, your repos that are in yours or that you've starred will show up on the left-hand side, and you can also get similar things on the right-hand side. So it's kind of an overview of GitHub's GUI. Some of that, a lot of that information, at least the descriptions of it, is also in the tutorial. How it describes all of these. And then if you're in your code section, you can click on the commits, the number of commits, and it shows you the commits themselves. So you can see all of the commits, and you can click on these buttons to browse the code at a certain point as well. And all of that is also in the tutorial, so you can look back on it later and when you need to, if you need to do these kind of things. Great. Great. So we're going to move on to one of the probably most complicated topics of the workshop, pull requests, merging, and things like that. Everyone doing good? Great. So merging and pull requests are a pretty central part of Git, GitHub, and code development. So we've talked about branching, but once you've been working on a branch for a while, once I have this awesome feature branch that has this great sentence I've added, what if I want to add that into my main branch once I want to combine them? Well, that's what you can do with a pull request. So if I have this branch, awesome feature, I've switched to it, I'm going to publish this branch now on GitHub. So in the same way as before, I can say publish, this now says publish branch. I'm just going to publish it. If I go back to GitHub, or if you go to repository, you can say view on GitHub and it shows you there. You'll see that there's two branches here now. And if I go to the over here on the left, it says main and awesome feature, awesome feature. So now both of them are on GitHub. So there's also in the tutorial an alternative way to find your repository on GitHub, not through GitHub Desktop. So you can look at that if you need to at some point, if you want to figure out how to do that. So if we want to create a pull request, if we want to merge our awesome feature into the main branch, so all of those changes are together, we can go to pull requests, new pull request, and then see this, it asks us which branches we want to do. So this arrow is telling us what direction the commits are going. So they're going to come from feature, awesome feature, and they're going to go in the direction of the arrow to main. That's how you can tell which branch you need to put for which one. Now, when I do this, it'll give me a preview. It'll tell me what commits are a part of this branch that will get added to main. So it's one commit, and it'll show me what files will be added or changed. And then I will click create pull request. As a quick little thing, you can also, if you've just pushed to a branch, GitHub will often be smart enough to say, you've just pushed to this branch. Do you want to create a pull request? Because that's usually how it works, is like you don't create pull requests after a branch has been sitting there for a month. You like push it and then you immediately open a pull request. So you can also just do compare and pull requests, and it's already figured out the two branches. So that's a way to shortcut it. So once you've done that and you say open pull request, it has you add a title. It will try and add a basic title for you based off of the commit message you've added, if you've added one or more commit messages. The more commit messages you've added, like the more commits in it, the less that is going to be helpful a lot of the time. But you can add a little commit message. A little side tip you can do, if you copy the text in the commit, then it doesn't just copy the text, it actually copies like a little hyperlink to that commit itself, which can be helpful for reviewers. If it's not just you, if it's like a reviewer, and they can actually click on a commit to see what was changed and all of that. This is just one commit though, so I'm going to leave it like that. I can do things like add a label and say that this is an awesome enhancement feature and a documentation feature, so that way later I can sort through my merges and see which ones were documentation and things like that. And there's some other things you can add to, like I could request someone to review it if there was someone else in this repo besides me, et cetera, et cetera. And then I'm going to click create pull request. And it does a quick check to see if there's any conflicts, any problems with it that require, that are just basically conflicting lines. There aren't any. So once I've done that, you'll see that I'm going to be able to merge it. So just go over this interface real quick. The first one is conversation. You can add, you or anyone else who's a part of the pull request can add comments. So I could add a comment that's like, hey, do you think I should add a line about the other awesome feature? And then if there was someone else other than me, they could reply and we could have a conversation about it. And we could talk about it if we are working in a collaborative environment. There's a commit tab that shows you all of the commits. People can click on them. They can view what was changed on those one commits. I don't have any checks running on this PR. There's no tests being ran. There's no documentation being built or anything like that. And then you can view the individual files that are changed, like the summation, not just on a commit level, but the whole sum, the whole diff, the whole PR. When you're looking at the files, you also can comment on lines, which can be helpful for the conversations. But once you're all ready for that, you can merge the pull request. And now it's been merged. And so I added awesome feature.markdown into main, and you'll see it is now on main. Awesome feature.markdown is there. So now, if we go locally though, if we go back to our main branch, we don't have that yet. Awesome feature.markdown is not in our repo yet. And that's because the GitHub version of our repo, a remote version of our repo, the remote repo has done this merge request, has merged it and committed the merge, but we haven't told our local version to grab those changes. And so now because it doesn't just do that, it doesn't sit there waiting, regularly asking GitHub, hey, have you changed yet? Have you changed yet? Have you changed yet? So it doesn't know when GitHub changes. We need to tell it, hey, go grab those new changes. Go fetch them. So back in GitHub desktop, there's this button at the top called Fetch Origin. If you click it, basically what fetching does is fetch grabs all of the information about the remote. It doesn't actually get those commits, but it tells your repo what is different about the remote repository versus your repository. And so it now has an understanding of your main branch and the remote main branch. And so then you can do a pull and you can actually grab those changes. So if we fetch and then we pull, then we can get the changes and we can see that it actually shows up in our main branch. And if we look back in our commit history, add new feature file awesome feature is also in our main branch history as well, a few commits back from when we did it in our timeline wise, it's when we did it before in our other branch, because it just slots in there. A lot of Git clients other than GitHub desktop will have what's called a sync feature or fetch and pull, and they will do those two steps of fetch and then pull. They can do those at the same time. So if you're using a different things inside GitHub Desktop in the future, you might see something that's like sync or something like that that'll do both of those together instead of as two separate steps. Yeah, so we're now going to, is there any questions about that? Are we good? Everyone caught up? Okay, we're going to move on to chapter 11. So now we're going to talk about merge conflicts. This is what happens when, if you're, how to pull on desktop? Yes, I will show that real quick. So if you, so on GitHub Desktop, in the top area, you can click Fetch Origin right here. And then I can't do it because I don't have any changes. So if you click Fetch Origin, like this button, and there is something to grab, then that Fetch Origin will change to Pull Origin because there will be commits. It is generally best practice to delete old branches after you have merged them to remove bloat. Yeah. When we merged, when we had this PR, there was an option to delete the branch, and I just forgot to mention it and do it. So you can delete that branch after you've merged it, and that will delete it on the remote. You still have a local copy though, and so you have to delete that locally. But yeah, it's generally okay. It's possible that you fetched and pulled it really quickly, and then after it pulled, it no longer shows it, and it's already pulled, maybe, or the merge if you didn't merge on the remote, then there wouldn't be any changes. Those are my only two thoughts. Other than that, I don't know, but we could troubleshoot it maybe later. Yes, it will. This is being recorded and we'll be posting it. But yeah, it's generally best practice to delete an old branch afterwards. I also did not realize that GitHub Desktop has a delete on remote button, so it'll do it for you, but I already did that. So great. So let's say you are, so if you have a branch and you've modified things in two different branches on the same line, then you can create what's called a merge conflict. And those are, so Git will try to resolve any conflicts when it merges. And if two branches never change the same lines, things should generally work out and just merge together. But if two branches have changes on the same line, then Git has to know which of those conflicting changes you want to take, or some combination of them, or neither. So that's what a merge conflict is. So if we go back to GitHub Desktop, so we are on our main branch, and we create a new branch real quick called feature conflict setup. So I'm just going to create a conflict setup here. I'm going to go back to my text editor. I've added some text that you all can add at the bottom. So I just added conflict setup at the bottom. I'm also just going to like mess around with some other parts of the code. doesn't really matter too much what you add. Just if you add the bottom, and then you can feel free to mess around with what you want. And then I'm going to go back and I am going to commit this. So I'm just saying create conflicts for a merge conflict example. I'm going to commit it. And because I'm going to want to show this on GitHub, I'm going to just immediately publish this branch. You could keep it locally, but you could also publish it. I'm going to say immediately publish it. You can keep it locally and publish it later, but we're going to need to publish later. So I am going to go back to main. Oops. Did it again. And I am going to add this section, which is a slight different version of what I just added. And I'm going to mess around with some stuff again. Yeah, just add some stuff. Mess around with it. And I'm going to go back to main. And I am going to commit it. Add conflict setup to readme. I am going to commit that, and I am going to push it. So if I go to GitHub, we can see the feature conflict setup. It's like, do you want to create a pull request for this? We do want to create a pull request for this. But we'll see that this time it says can't automatically merge. And we'll see that there's a number of spots that it's mad about. It has like changes that are being changed in both ones. So I'm going to, but it says you still can create the pull request. So we still are going to create the pull request. So once again, this merge conflict happened because we edited in two branches, the main branch and the conflict setup branch, the same lines in different ways. So it doesn't know which of those branches to take for those specific lines. It doesn't know if on this line, do we take the mains version or the conflict setup version? So there's two different ways we're going to go over how to resolve this. GitHub has a native inbuilt conflict resolving tool. So in your PR, you can go to resolve conflicts, and it will highlight right here in yellow all of the main problems. And so how this is basically read is this one right here, that's this arrow. This is saying this is coming from this branch, feature conflict setup. These arrows on the bottom pointing at it, this one's coming from main branch. This is a divider, and it's asking you which of these things do you want to take? Do you want to take this one or do you want to take this one? And it does that for every single thing. And so GitHub's conflict resolver is you have to go in and manually modify these. So you have to remove these lines, the divider lines, and then you decide which one to take. So in that case, I took main. Let's say this case, I want to take feature conflict setup. So I can delete the one for main like this. I'll just delete the main one. And then I also have to delete the feature conflict setup thing. And then let's say for here, I want to take mains version here. I am going to delete feature conflict setup here and the thing around it. And I delete the extra arrows pointing at main. And once I've done all of those, all of the yellows is gone and it will be resolved. So that's how you do it if you want to use the GitHub conflict resolver. I am not going to save this because I am going to show you how to do it the other way, which is to do it locally, which at first sounds a little bit more complicated, but can be a lot easier. So if we switch in GitHub Desktop to the branch that we're putting the PR from, so conflict setup, and we go branch, and we say merge into current branch, and we say we want to merge main. And so basically the idea for this one is we're merging conflict setup into main, but if we first merge main into conflict setup, we can resolve all the changes locally, and then we can push those changes, and then the merge conflict will have been resolved because we did a merge locally, and then we can do the PR on GitHub where it can be documented. That's the idea. And the reason why this sounds more convoluted, but the reason why you would want to do it this way is a lot of tools other than GitHub Desktop, like the tools integrated with VS Code or RStudio or PyCharm or the third-party GitHub clients like GitKraken, all have much better merge conflict tools than GitHub Desktop or GitHub. So if I say merge main into feature conflict setup, and then it's like, oh, there's a merge conflict. You have to figure this out. So I say open in Visual Studio Code, and you can see it's getting us a similar interface, and different tools will have different interfaces, but this one's giving us a similar interface. And so instead of me having to like modify the text directly, I can just say accept current change, and then it just does it. I can just say accept incoming change, accept incoming change. And then it's done. Like I'm able to just click which one I want. And then, or there's other views that you can use that also do similar things, but in different options. So that is now, that's all done now. And so now that I'm done with that, I can go back to GitHub Desktop and say continue merge because I've resolved all the conflicts. And then I just push that. And you'll see that there's a new commit basically saying merge main into feature conflict, and that was the one that resolved all of those conflicts. And now it has no problem with this merge because there's no more conflict because I resolved them locally. And I'm able to just merge it. One other note about that is if you read the bottom section of the merge conflict section, the tutorial, you also might want to pull and merge locally when you're developing a long-running branch. So if you branch off of main or develop and some feature branch, feature, add awesome new thing to my model, and this thing takes you 3 months to do it. Well, the other branch, the branch you branch off of, main or develop, might have a lot of changes while you're working. So when you finally try to merge it back into main or develop, there might be a lot of conflicts. And so a way to minimize this big merge conflict that we just, like the merge conflict we just saw, but it could be very big at the end, is to regularly do a pull main into your branch like we just did locally. Just do that regularly, and you basically break up this really big conflict into little tiny easy to do ones along the way. So that's another reason you want to do it like that, is you can do these local ones along the way to make your the one at the end a lot easier. This is all of the main stuff I wanted to, the big hard stuff I wanted to get through. We only have like a few more minutes, so I just wanted to quickly go over a couple more things. The next chapter is basically talk about cloning and forking. A clone is when you take a repository on GitHub and that's like already on GitHub, and you download it yourself. And GitHub Desktop has ways to do that. You can do file clone repository, or you can go into the repository view and add clone repository. And so if you have deleted your own local version of your repository, if your computer died or anything like that, that's how you would re-download it, is you would click clone repository. Or if you want to look at someone else's code, you can click clone repository. Now, if you're not just looking at someone's code, but you wanted to make edits to it, whether that's your own version of it, like a new version of the code, or you want to propose edits to their project, you can do what's called a fork of the repository, which is making your own version of the code, and you get your own version of the repository, like your own repository. And there's a section talking about how to do that if you need to do that. There's a section on licensing. So whether you're working on a project that you want to have an open kind of license that lets people reuse your work, or a closed license, whether you're not sure if you can do that or not. And another cool thing about software stuff in academia especially is people are now starting to cite software a lot more. And so in GitHub, you can connect your code to Zenodo to get a DOI for your code. And GitHub and Zenodo both have documentation on how to do that. And it can do it automatically. And so you can have one DOI for the whole repository, or you can have DOIs for every time you release a new version of your code. And it will give you new DOIs for that, which is really great. And then there's a little section talking about the different alternatives for GitHub, GitLab, and Bitbucket. But I think getting through merge conflicts was the big one I wanted to be able to get to. I think that is mostly what I wanted to talk about. If anyone has any questions, we can talk about questions. So someone asked, how would making a private branch differ from making a fork in someone else's code? So a lot of the time, if I go to Pandas, like the data analysis library Pandas, I can clone this. So I can go in here and grab this URL and I can do git clone. I can clone it so I can have a version of the code. But if I want to propose a change to Pandas, if I have this really cool algorithm to do some kind of thing or whatever, if I want to add to Pandas, then I don't have permission to. Like, their permissions are such that I can't push to the repository directly, because Pandas is set up so that way. I don't actually know if this for Pandas. I am almost sure that most repos are set up this way, that random strangers can't push to it to prevent people from messing with code. So I can't push directly to Pandas. Which means I can't make a branch myself and push to Pandas. I would have to make a fork and make my changes in my own version of their repository, and then create a pull request from my fork into their code. So that's why you would use a fork instead. And the other reason is if there is this really cool package that does something that you like or whatever, and then the people just stop maintaining it. Often you can't get a hold of them to take over the repository, but what you can do is you can fork it to make a new version. So if, let's say, the people in Pandas just stop maintaining Pandas, I don't think that's going to happen because Pandas is one of the biggest packages in Python. But let's just say they stop maintaining it, but you wanted it to live on. You could fork Pandas to Pandas 2 or whatever, and then you could maintain it with whoever you wanted. and then you could release pandas 2. And that's why another reason you make a fork. Great question. Thanks. Thanks, Claire. Thank you. Any other questions before we sign off? So, question was asked, where are the files stored for different branches? So how Git works, repository, show and finder. If you look in my folder for this webinar's repo, I have a hidden folder. I have my finder set so I can see hidden folders and files. You might have it set so hidden things, which are hidden are started with a dot. So those are like hidden things, which are usually like system files or folders, and therefore most users don't need to see them. And so they're usually hidden and not shown by default, but I have it set so I can see them. But there's a .git folder. And this is where everything in your repo's information is stored. And so all of the stuff is stored here. There's information about branches in there. There's logs and all that. And so the different branches are stored in this folder. The commits are stored in this folder, and everything like that. Git uses a pretty complicated algorithm that stores commits as in succession, as like linking commits to their parents and the labels associated with commits, whether it's branches or tags or things like that. And it tries to intelligently figure out whether it should store, because it'll store like an initial file, like a compressed version of a file when you commit it, and then it tries to intelligently figure out if you make a really small change, it won't store the file again because it'll just store the difference you made between the file. It'll just try and store that because that's much more efficient. But then at a certain point, if you make enough changes or if you make a bigger change and all that, it'll just store the file again because that's more efficient. So it tries to figure out when to do that and things like that. And so all of that's very complicated and sophisticated, and I don't know all the details for that, but that's generally how some of it works. And there's a .git folder in the top of your repository. Awesome, cool. Well, thanks everyone for coming.